Hello, and welcome to How Autonomous Drones in AWS IoT Core Improve the Delivery of Medical Supplies. When you joined today's webinar, you selected Join either by phone call or your computer audio. If for any reason you'd like to change your selection, you can do so by accessing your audio pane in your control panel. Also, from this control panel, you'll have the opportunity to submit questions to today's presenters by typing your questions into the questions pane. We will collect these and address them during the Q&A session at the end of today's presentation. If you're not able to get your question, we plan on responding to each of you personally through email. The recording of the webinar will be available in about a week after the conclusion of this presentation, so keep an eye out for that email. My name is Cameron Habib, Senior Solutions Architect at Amazon Web Services, Inc., based out of Melbourne, Australia, and I'll be your host and moderator for today's webinar. Joining me today is Zoran Angelowski, a Principal Consultant of IoT at DiUS, and Andrew Thomas, Chief Solutions Architect, Swoop Aero. So we start off with the speaker introduction for today. Next, I'll give a short presentation on what were the key tenets that have underpinned the solution developed by Swoop Aero and DiUS, and also a brief overview of data and analytics on AWS. My presentation will be followed by Andrew's presentation on Swoop Aero's drone logistics solution. Then Zoran will discuss how DiUS helped build production-grade devices for drone. We'll follow the session up with Q&A and next steps. We know that data is a strategic asset for every organization, not just new businesses. Data has gone from being something that was cumbersome and expensive to store to becoming the lifeblood of many companies' business model. David Parkins from The Economist in 2017 rightly called data the world's most valuable resource. Over the past 5 to 7 years, a couple of key trends have got us to this point. Number one, connected devices, apps, and systems now generate more data than ever before. Secondly, with the cloud driving down the cost of storage, customers no longer need to decide what to keep and what to throw away. And thirdly, with the cloud providing pay-as-you-go on-demand compute, organizations can now more easily analyze their data and gain insights in a variety of different ways. So if you're able to store every relevant data point about your business and have the ability to analyze all of that data in different ways and distill the data down to insights for your business, it will fuel innovation in your organization, which can lead to a competitive advantage. But before I briefly give an overview of data and analytics on AWS, I'd like to identify 3 key tenets that underpins the solution developed by Swoop Aero and DiUS. First, global comes standard on AWS, with 255 countries and territories served, and with 24 regions, with a further 3 regions announced all over the world, as you can see on the map. It is because of this global nature of AWS Cloud, as you'll see today, that customers like Swoop Aero can run their operations in countries worldwide, such as Mozambique, Malawi, Democratic Republic of Congo, Australia, and others. The second tenet that the solution is based on is a strong security foundation, underpinned by AWS's shared security, shared responsibility model. Security at AWS starts as our core, custom built for the cloud and designed to meet the most stringent security requirements in the world. Our infrastructure monitored 24/7 to help ensure the confidentiality, integrity, and availability of your data. Looking at our global network, all data flowing across the AWS global network that interconnects our data centers and regions is automatically encrypted at the physical layer before it leaves our secured facilities. The third tenet that the solution is built on, and you'll see this repeatedly mentioned in the presentation today, is the AWS well-architected framework, which is a mechanism that helps you be successful in your cloud journey. It codifies the best practices for architecting in the cloud, where you learn these best practices. Then you measure against these practices your architecture, and then continuously keep improving your architecture by addressing any issues as your architecture changes and evolves and matures. Creating technology solutions is a lot like constructing a physical building. If the foundation is not solid, it may cause structural problems that undermine the integrity and function of the building. If you neglect the 5 pillars of operational excellence, security, reliability, performance efficiency, and cost optimization, which are part of the well-architected framework, when you're architecting technology solutions, it can become a challenge to build a system that delivers the functional requirements and meets your expectations. When you incorporate these 5 pillars, it will help you produce stable and efficient systems and allowing you to focus on functional requirements for your business. So moving on to data, we hear from companies all the time that they're looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially, coming from new sources, is increasingly diverse and needs to be securely accessed and analyzed by any number of applications and people. Analytics is a broad space, but some common use cases emerge for most businesses, such as data warehouse modernization, big data and data lakes, real-time streaming and analytics, self-service business analytics, and acquiring third-party data for analytics and others. You'll see how Swoop Aero and DiUS use their telemetry for operational and search analytics and beyond in today's presentation as well. Getting answers quickly means spending less time building, plumbing, and configuring cloud analytics services to work together. AWS helps you do exactly that by giving you an easy path to build a data lake and start running a diverse analytics workload. Securing cloud, storage, compute, and network infrastructure that meets the specific needs of the analytic workload and the shared security and responsibility model. A fully integrated analytics stack with a mature set of analytics tools covering all common use cases and leveraging open source and standard languages, engines, and platforms. And lastly, the best performance, the most scalability, and the lowest cost for analytics. To eliminate silos, you need to build a data lake, but that's not always been easy in the past. AWS makes this simple to build a comprehensive and secure data lake environment so you can start getting new insights from all your data fast. AWS Lake Formation, which automates many of the complex steps required to set up a data lake, reducing the time required to build a secure data lake from months to days. Security control at the object level for our object storage at the data lake storage layer. Deep integration across services that are needed to get answers from your data, including storage, compute, networking, and data movement. For example, Amazon Redshift allows you to query your S3 objects directly from your data warehouse, giving the fastest way to go from zero insights to covering all the data for all users. As organizations face a growing number of data breaches, cybercrime, and the need to meet compliance regulations like GDPR, their data needs to be protected with the highest levels of security. AWS provides essential security, compliance, and audit capabilities with all of the services listed across security, identity, encryption, and compliance available as needed. The breadth and depth of analytics services on AWS makes it easy to choose the right tool for the right job. From the fastest data warehouse service to a fully managed Apache Spark and Apache Hadoop service, AWS Analytics makes it easy for you to spin up the right resource to run whatever analysis is most appropriate for your specific need. AWS supports and participates in both common industry standard languages, platforms, and tools, and also open source software choices. This lists many examples where customers can trust that AWS brings them an easy adoption path and future flexibility. Analytics requires robust storage and compute to get performance at the right cost. Amazon EC2's industry-leading collection of instance type, reserved instances, and spot instances make choosing the right compute for your analytics workload simple. And 100 gig per second network interfaces provide an order of magnitude more bandwidth between storage and compute, increasing performance and reducing costs. Amazon EC2 provides over 200 instance types to meet the needs of any workload. Amazon S3 provides the world's highest availability with 11 nines of durability, making S3 uniquely well suited for data lake storage. In addition, S3's 5 storage tiers and intelligent tiering make storing vast amount of data less expensive and easier to manage. With that, Andrew Thomas will present the Swoop Aero solution. Andrew, over to you.
Thanks, Cameron. I'm Andrew Thomas, Chief Architect of Swoop Aero, and I'd first like to take the opportunity to introduce Swoop Aero and what we do. I'll then cover off the areas that we've worked with both AWS and DiUS before handing on to Zoran to cover that in more detail. We are an aeromedical logistics company which integrates air transport into the last and first mile of the medical supply chain. The organization was founded in 2017 by ex-Air Force pilot Eric Peck and robotics engineer Josh Tepper to transform the way the world moves essential supplies. The company was founded off the back of the question from the Australian government as to whether a drone could be used to transport chemotherapy medication in rural Australia. The answer to this question was yes, it's technically possible, but our founders found the real question to be, what did a system look like that could do this sustainably, reliably, and safely every day of the week? By combining our founders' experience, the company transformed a Hercules aircraft into a 20-kilo 3D printed electric drone and simplified all the systems and processes surrounding aviation using software to build a full logistics platform. We only operate in healthcare and have been trusted to do so by the world's biggest names in global healthcare. In practice, we deploy a two-way logistics service and utilize a full integrated aviation system. To date, we've deployed our service successfully across 5 countries. We're on track to reaching our goal of providing a sustainable logistics service which reaches 100 million people by 2025. I'll now focus a bit in particularly on Malawi. We've had operations operating in Malawi since November 2019 in both the north and south of the country. In March 2020, as COVID hit and Australian default travel restrictions came in, Australian staff were forced to return home. The photos in this presentation were taken before that point. Fortunately, we had our Swoop Aero local Malawi staff who were able to continue operations as hub operators. The Malawi Department of Civil Aviation granted us the approval to pilot the drones from outside of the country. This made Swoop Aero the first drone logistics company globally to operate a fleet of aircraft from outside the country of operations. That network has continued to operate throughout COVID, and the aircraft in Malawi are now being used to transport COVID test samples to greatly improve the speed and reliability of moving test results around. This is a screenshot of our remote pilot station in an observer-only view of the drones operating in part of the southern Malawi network. This screenshot includes Nasanje down the bottom and a pod swap location called Kalemba, which is used to swap the pods, which also include the battery, over to extend the network coverage. On the left, you can see the various drones in various stages of flight as they operate between. And on the right, the pre-planned routes, the lines that the drones are tracking, and the autopilot will fly throughout the operations. Here's a short video from earlier this year showing a delivery on the Malawi network, flying to a remote location and a push-button relaunch to send it on its way home. Okay, so hopefully that gives you an idea about what we do. I'll now cover in a bit more detail some of the areas we've worked with AWS and DiUS, being IoT device management and security, flight log analytics, and finally, the well architecture review. Our drones fly with an onboard autopilot system, which interfaces with the pilot screen you saw earlier with the addition of command functionality. We don't use basic point-to-point communications, as you'd see on a lot of private drones, and those are designed to fly what we call line of sight, within line of sight of the operator. Instead, our operations are flying beyond line of sight in areas with poor network coverage. We hence implement a mix of both terrestrial and satellite communication links to link back to our remote pilot station for control and to provide interfaces for third parties. The drones have an onboard companion computer performing tasks such as computer vision, as well as interfacing with these channels of communication and AWS IoT Core. But this platform also enables us to open up interfaces for air traffic control or any unmanned traffic management systems where it's available within a particular region of operations. This overall functionality has been key in enabling us to achieve the high scale global operations we have been, and in particular, the international flight operations we referred to operating out of Malawi, I referred to earlier. To achieve the scale we're working towards, we needed to achieve some things with our onboard companion computer and had some key goals. Firstly, whatever we did, it needed to be sustainable in that we wanted to grow to thousands of drones around the world operating on a 24/7 basis. We need to be able to essentially manage these drones and update them with new safety or feature improvements. In doing this, we need to be able to push those updates reliably and with confidence of knowing exactly what we're deploying across the full OS layer. Safety is also at the core of our industry. Hence, security played a significant role in what we wanted to achieve here. We understand security needs to be done at all layers across an architecture and wanted to ensure that we had maintained a high level of security over our end device. We hence worked with DiUS, bringing their significant experience in this area to both scope out what we should do, as well as implement a solution, which Zoran will cover later. So now moving on to log analysis. Every flight, the autopilot that's on board, captures a significant amount of detail in what we call a flight log. I'll talk to the exact details of this shortly. But firstly, what we wanted to leverage from this. We wanted to be able to minimize operation costs and improve safety by implementing intelligent data-driven maintenance to ensure our growth remained both sustainable and the reliability of our platform continued to improve. We also wanted to be able to use data-driven insights to improve our product, as well as the ability to provide evidence to external regulators on the safety and reliability of our platform. Each aircraft captures more than 300 megabytes of information per flight. This adds up quite quickly across many flights. And similarly to building an AWS production environment, our aircraft are fitted with significant hardware redundancy, with removing any single point of failure, with multiple sensors across the board, for example, airspeed, GPS, or inertial management unit. The log outputs that come out also include synthesized data, such as an extended Kalman filter, which is an onboard state estimate based on the many sensor inputs. This data is quite complex, with every component having its own unique set of values and each logging within its own time step, some up to 400 times per second. On an individual basis, we had the tools to review these manually and graph and look at the data on a single flight. But the great power comes from both the automated analysis as well as the aggregated insights that could be looked across the many thousands of flights. This aggregate analysis was quite challenging due to the complexity of the data. And standard data analytics that we'd use for our business type data wouldn't quite work for us. So we had this more unique approach I'll now cover. Firstly, how do we get the information? So during flight, the autopilot is saving flight logs to what we call the pod, which also contains the batteries. Upon landing, the pods are removed from the aircraft and placed on what we call a pod dock. The pod dock extracts the logs, as well as also charging the pod. Upon extraction of those logs, the pod dock will push those logs up to AWS S3 for long-term storage and kicking off our analysis pipeline. I'll let Zoran talk to the analytics pipeline later on, but I'll now just highlight how we use it. Firstly, automated flagging actions based on the logs. So an example scenario is we have multiple airspeed sensors on board. If one airspeed sensor was reading slightly misaligned to the others, it doesn't cause a problem for flight. But from a log and an analytics perspective, we want to flag that sensor so it can be replaced or repaired before the aircraft flies again. The system will automatically log what we call a defect against that aircraft. And our remote pilot station checks our operations platform before every takeoff and prevents the aircraft from launching if there are any open defects. We also wanted to feed back insights into our product development, as well as further enhancing our live onboard monitoring, driving the insights from the huge aggregate data to improve the onboard live monitoring. And finally, we wanted to use the platform to provide evidence back to aviation regulators on the safety of our platform. This is various regulators across every region that we operate. To achieve our company objectives and have a global scale of thousands of drones operating worldwide, we needed our platform to be scalable, resilient, and secure. Above, I've included some of the components of our end-to-end platform, but there's a huge amount of components that come together to make this happen. Building on AWS alone would not achieve these pillars. The system needed to be designed to leverage the tools available, and we worked with both DiUS and AWS on the well-architected framework to ensure we're achieving these goals. Although we had significant skills internally, our platform had significant breadth in technologies. So working with AWS and DiUS allowed us to draw from a mixed set of skills to review and help us ensure we maintain best practices across the board. This includes, for example, the significant work we did on device management and security, an area we relied on DiUS's expertise in both scoping and implementing that piece of work. I'll now hand on to Zoran, who will cover this work in more detail.
Thanks, Andrew, and also thanks, Cameron, earlier on for the introduction. So I'm Zoran Angelovski. I'm one of the principal consultants at DiUS, and really my focus area or my area of responsibility is in that IoT space. And specifically, I actually manage the team of developers that work on physical devices. So that's the hardware and the software that operates on those physical devices. And these days, almost all devices that we work on are actually connected and rely on a cloud service, such as the drone from Swoop Aero. More broadly, DiUS is essentially a technology company. We're approximately 130 people across a variety of skill sets. And for the most part, or about 90% of those consultants, really they're involved in the development cycle. So that can be anywhere from user experience to web developers. And as we did in this case, for helping out with Swoop Aero, we relied on our hardware and software developers, our IoT cloud specialists, but also our team of data scientists as well. So I'd now like to talk a little bit about how we actually contributed to the development of the Swoop Aero drone. But firstly, I'd like to recap on some of the critical points that Andrew really was talking about. And quite often when we go through these presentations, we can have quite a technical angle, but really I think it's good to bring us back to what some of the goals and objectives that Swoop have as a business, because really that drives what we do then from a development and a technical point of view. Essentially, what resonates to a great extent with us is really the mission or the goal that Swoop have of reaching 100 million people where they deliver these critical services across really what will be the globe. And in addition to that, how they're actually looking to achieve that. So they're already operating a service in that sustainable and reliable and safe manner every day of the week, but now they're actually looking to move to scale. So that's critical. So how do you then take that service and scale it up to those thousands of flights and that 100 million coverage around the globe? So we'll now talk about what we actually did. So we worked in 3 core areas, as Andrew touched on earlier. Firstly, we assisted in what we will refer to throughout the presentation is really production-ready software, and which means that you can actually take that software out to scale. So typically, when we undertake a development like this, there'll be a core component. In this case, Swoop have selected a single board computer module from a supplier or a manufacturer called NVIDIA, and they will provide certain capabilities as far as the software is concerned. But that's not something that you can necessarily readily take out and to scale in production. So I'll talk about how we actually bridge the gap from what you may get as a standard image from one of these suppliers, which supply actually quite powerful processors, but how do you bridge the gap between what they supply and what you can actually deploy at scale? The second bullet there is really around the data and analytics, and there was some specifics and some specific challenges that we actually had for this project, not just simply around the amount of data, and Andrew talked to that. It was that in that sort of range of 300 megabytes per flight, but you extrapolate that out to many thousands of flights, and all of a sudden you have a great deal of data. But it's also the type of data that we're collecting as well, and how we deal with that as well. Now, the last point that I have here, and the last area that we actually contributed to, is really that review of the well-architected framework that's done as a team. So it's with Swoop as the domain experts, as DiUS, as I guess experts in the technical area, but also supported by Amazon as the underlying infrastructure providers. Now, I won't talk to that topic in detail, other than to say it is what we provide for our clients. And where we really differentiate ourselves is having that deep understanding, not only in the device space and what it takes to operate a physical device, but also how we couple that to the cloud infrastructure as well. So when we kicked off the early stages of this project, we actually spoke to some of the objectives and guiding principles that Swoop had. And I'll talk a little bit to those right now, because they really were central to what we did. Firstly, Swoop needed to deploy a managed air transport service, and it needed to be done at scale. So what did that really mean? Well, essentially, to do that, you need the ability to be able to remotely manage these devices, and that involves remote configuration, remote firmware upgrade, and we saw that in particular during the COVID period, where a team in Melbourne was managing a device out in Africa. So it's quite central. So if you're looking to scale and deploy this more broadly, you need a way to manage it. But essentially, you also need to actually deploy with production grade software, or firmware as I've called it here. So we'll unpack that a little bit in a little while and what that means. The next bullet here really is around device security and the fact that it is critical, in particular with a device like this that actually is out there. We need to consider not just the physical security aspect and the implications across the board, but all the different layers that are within the drone from a software perspective. So really we need to look at how do we actually minimize potential attack vectors, and what does that mean? How do we lock down the device, not just on the periphery, but internally as well? And then what does drone authentication look like? So how do we ensure that only drones from Swoop are actually operating under this service? The last point there really is around the analytics capability. Now, we spoke to the actual volume of the data of that, but we needed a way to collect the data, but then actually then process the data at scale. So we'll talk a little bit about that as well. Now, before I get into the detail, as I mentioned earlier, we actually leverage a single board computer module from a company called NVIDIA. It's quite a powerful computer module. And I also mentioned, I talked about bridging the gap between what a supplier might give you and where you actually need to get to. So what do you get out of the box from one of these suppliers of the single board computer modules? Well, essentially you get a standard image, and quite often we refer to it as a stock image. Now that stock image is really made for development purposes. So you get a lot of development tools, they're all included, and that's quite convenient. Additionally, that image is quite heavy. It's about 12 gigabytes in size, and it really fundamentally is made to work with a desktop environment, which is unlike, of course, a physical device that's deployed out there. Now, that desktop environment is really quite flexible, and it's really made to interact with a person. In this case, it happens to be a developer. So as a developer, this is really exactly what you would want, because the platform that they give you, it's highly flexible. You can develop code, you can produce code very quickly. Now, when we consider it in the context of a drone, it's actually not what we want. A drone or a physical device, by comparison to that desktop computer, really has quite limited resources. It has finite memory. It actually also needs to operate off a battery, so it's not plugged into a power source. But critically, really it needs to work without interaction. Unlike that stock image that we get from the vendor that's made to interact with the person, when we deploy the software in the drone, it needs to largely do its thing on its own without reliance on a person really doing anything. Okay, so now I'd like to talk a little bit about what makes a production grade software image. Now, it may take a little bit of time to get through this, so please bear with me. And when we talk about this sort of thing, really there's a number of key areas that we need to cover. The first point is really around how do we protect critical components of the drone, and really here we're looking at it in the software context. And the operating system that we've actually deployed on the drone has a number of components. One of the key components we refer to, we call it as the root file system. That root file system really has all of the software that enables us to start up the drone. Now, what we do is we make that part of the file system read-only, because really if we corrupt that, if we accidentally write into that part of the file system, it can be quite disastrous. Essentially, we could end up with a device that we can't actually start up. Now, the other areas of data that we deal with, and storage, if you like, on the drone itself, is when we deal with all that sensor data that Andrew spoke to, but also the configuration data that we need to apply to a device so that it behaves in a particular manner. Really, we need to keep these two different data sets completely separated. So we go to great lengths to separate those two so that they actually don't cross over, because if we have something writing into our configuration where it's not meant to be, you can imagine how disastrous things can actually happen. So there's quite a bit that we go through to protect those critical components. Now, the next point I have on here is really about using only the required software that we absolutely need for a physical device. And I don't want to understate this because it's actually quite a critical point. So we saw earlier the standard image or the stock image that we get from the manufacturer was about 12 gigabytes in size. And we've reduced this down to around about 700 megabytes, which is really 1/20th of the original size. Now, that's critical for a number of things. Firstly, as I mentioned earlier, we have a resource constrained device. On this device, we only have about 16 gigabytes of flash memory, so we need to be mindful of that. And the 12 gigabytes, although it fits, it's still a sizable amount. But critically, what we have done by reducing that stock image when we go to our actual final production image is we've removed 11 gigabytes of software. Now that's 11 gigabytes of software that has the potential to be a security problem for us. So essentially what we've done is by removing that large part of the software that's not needed, really we've minimized the attack vectors on our device itself. The third bullet that I've got there talks to really maintaining version control of the libraries that we incorporate into the product. So the way the device is constructed from a software point of view is there's application software, but there's some 50 odd libraries that we leverage from third parties, where really they're standard tools that might be needed. And there may be simple things like a software module for keeping time, for network timing protocol. And all of these are built, packaged up into the device, and we need to keep strict control of this. And the reason for that is that we only really want to use verified software to build our software image that will ultimately go into the device, because the drone itself goes through quite a heavy test and verification process. So we don't want to be changing that software unnecessarily, because these third parties quite often make changes to the software, but the impact of those changes we really need to manage. So we only upgrade software when we absolutely need to. And I guess the other point there is we need to strictly define what versions of software we build with. That goes to the reliability and the predictability aspect of the drone itself. Now, the fourth bullet I have there is really around the remote management. And what we do here is essentially manage leveraging AWS IoT Core. It really gives us those capabilities to be able to configure and remotely upgrade the device as may be needed. And the other point that I'd make there is for that remote software upgrade, we need a way to do that that's reliable. So that if, for example, we update the software in the device, for whatever reason, that software fails, we need a fallback position. And the approach we take here is that we operate a dual image approach for redundancy. So what happens is that we have an image that's already functional in the device, we update to a new image. That new image must go through a series of checks, and only when it ticks off on all those checks does that new update image actually take effect. The last point I have here really is around the security and authentication. Now, really, this is a multi-layer approach, and it starts off down at the lower level, really from the hardware all the way through the application layer. So we build a chain of trust, and that chain of trust is achieved through implementing or using cryptographic keys, so that when Swoop deploy their application code, they know that only their application code that they produce will actually run on this device. And the last bullet there is really around how we authenticate the device. And here we actually leverage Amazon's just-in-time capabilities for getting keys onto the device, so that we know when a drone comes up, it is actually an authentic drone. It is a drone from Swoop. Now, this is quite a simplified view, although I've taken a few minutes to get through this. Each of these areas is actually quite complex, and when we do this for a client, it can actually take a few days of workshops to get through this type of activity, unpacking each of these, and also involving some of our key people from the device team as well. Okay, next I'd like to talk about really the analytics side of the activities that we undertook. And it was really centered around how we obtain those deeper insights and those really powerful insights from the device itself. And we saw earlier there's quite a bit of data that's been collected through quite a lot of different types of sensors. Now, there was a number of areas that we actually looked at here, and in terms of the way we drove that activity. Essentially, because of the volume of data, really what we needed was to automate the pipeline. So really, we needed to extract these timely insights through large amounts of data. And the insights were not only obtained at a drone level, but it was also across the network of drones, and all of the flights, actually the thousands of flights that Andrew talked to. But there is a critical difference here that I'd like to differentiate in terms of perhaps a traditional analytics project. And essentially, this goes to the fact that we're dealing with drone data and it's actually not business data. And the drone data comes from all those disparate sensors that Andrew mentioned earlier. So these are lots of different sensors that monitor different things. The sampling rate for each of those sensors is quite different. So we end up with quite a mix of data, which is quite different to business data. So typically, business practitioners leverage off-the-shelf tools like ClickView or Amazon QuickSight, which are great tools, by the way. But these actually assume a particular structure of data that they're using, that they're querying. Now, Swoop doesn't actually have that type of data. Their log data is different to that, being a sensor data, of course. And all those tools that I just mentioned, really they're quite focused on a graphical view of representation. But the aim of the log analytics for Swoop was quite different. It was about getting those deeper insights and flagging certain things if they detected something that might not be quite as expected. So fundamentally, we couldn't actually use traditional data science and dashboarding. The device data really needed to be treated differently. So effectively, we needed to build a custom framework that Swoop could then build upon further. Now, we saw this page earlier on, the overall end-to-end architecture, and Andrew spoke to that. So I'll talk to really more to the specifics of how we contributed. And first, I'll start off with what was driving this. So essentially, we needed a way to timely process the log data and extract the information from the plane. So there was lots of data to be analysed and uploaded, and really we needed to get the insights or the interpretation of that data into the hands of someone that could actually do something with that data. And really, there was far too much data given the scale that we're trying to achieve to do this by hand. Therefore, that all needed to be automated so that we could get the speed of results. So how do we go about this? And essentially, there's a few key areas that we tapped into, in particular on the Amazon resources side of things. So we used S3 buckets, really for the large data lake store, which really stored data from those thousands of flights that we spoke to earlier. But we then used event-driven processes to trigger Lambda functions that would allow us to then run analysis in parallel. And this was quite critical in tapping into the capabilities of Amazon's Lambda capabilities for that fast parallel processing. But underneath all of that, essentially what we did was build a framework that Swoop could then take and extend by applying complex rules and applying some complex mathematics to determine those insights. So the custom framework really provided the foundation for Swoop to build further analytics upon. They could actually run these calculations, apply the rules, and they could do that in an automated and timely manner, removing that reliance on the manual processing. But really what that enabled was for Swoop to scale their ability to analyze the data and ultimately improve the performance of the data, not only on a drone, but overall the overall service that they deliver to their client base. And really this enabled them to achieve that sustainable, reliable and safe manner every day of the week, but importantly to produce that at scale. So that concludes my part of the presentation. I'll now actually switch back to Andrew for the next part of the presentation, and he'll give you some insights into where they're headed to next.
Thanks, Zoran. So I just wanted to quickly cover about where we'll go from here. So technically, the flight log analytics platform is something that will grow over time as we have more flights occurring and we add new analysis modules and continue to leverage that platform to grow our product. We'll also be able to leverage the IoT and remote update capabilities that we've worked on with DiUS to continue to accelerate and improve the safety and reliability of our product. As a company, our goal of reaching 100 million people by 2025 with a sustainable logistics service, we're on track for. We launched the DRC network about a month ago, together with a not-for-profit partner, Village Reach. This will be the largest drone logistics network in the world, servicing 25 health centres across 10 health districts and another 45 indirectly. These operations all run off the back of the AWS platform. We're increasing our global services to provide the same advantages in developed countries. The current pandemic has only served to highlight the need for a more resilient supply chain, medical supply chain. We are set to launch operations in Australia and New Zealand in the coming months, so watch this space. If you have a project or are wanting to understand more about our platform, please make contact with us. We're also in the process of expanding out our partner network as we expand globally. Thanks. I'll pass through to Cameron to go through the Q&A.
Zoran and Andrew, thank you for your powerful insights on the amazing solution you've built. We're now going to transition into our live Q&A. As a reminder, you'll be able to submit any written questions through the questions panel. In the event that we are not able to answer any of your questions today, we will follow up with everyone individually via email. So with that, Zoran, first question over to you. Why don't computer module vendors provide production-ready code?
That's a really good question. Thanks, Cameron. So typically, I guess, when you receive a product from some of these vendors, really their interest is in assisting you to develop your own custom code. So it's difficult for them to anticipate all the different ways their products can be used. So what they provide you is really with the capability for you to build your own code. But from that, you really need to then be able to take that code and productionize it. And it just isn't practical for them to give you a full production suite of code. That's really up to the really companies like Swoop to produce that code, with, of course, help where they need it.
Thank you so much. So next question to Andrew. There's a lot of excitement in the comments about the drone solution you presented. Can you tell us some more? Can you tell us a little bit more about the drones? For example, how fast and far do they fly?
Yeah, so you saw the network, the Southern Malawi network I showed you earlier in the presentation. That had 2 pod swap locations. They were about 80 kilometers away from each other. But our actual capabilities, the drones can fly up to 130 kilometers, carry 3 kilograms of payload, so a box that you may have seen in the video I showed you earlier, and fly at approximately 100 kilometers an hour. We leverage the pod swap locations that allow us to achieve an extended network and reach a great range.
All right, thank you, Andrew. Zoran, next question for you. Can you elaborate on what you mean by chain of trust with respect to security?
Certainly. So I guess that's quite a complicated answer to that question. So I'll really try and simplify it. When we talk security and really what we mean by chain of trust, I guess the first thing to look at is really what your device is. What's your starting point for your device? What's the exposure for the device? And that'll drive the complexity of the security solution that you actually adopt. And in this case, when we spoke to Swoop, really their device is something that's out there. People could potentially physically get to the device. So we need to look at it from the ground up. So it's really from bottom up all the way through the different layers of software, including the operating system that runs on the device. So fundamentally, for a device like that is exposed, it starts off at the hardware layer. So at a hardware layer, can you sufficiently protect those cryptographic keys that then give you the confidence to operate the underlying software that's on that device? It's really about building a set of keys across the different layers of the software, and each of those layers of the software having trust in what's underneath. So as I mentioned earlier, so that when Swoop actually go out to deploy their code, they know it's only their code that can actually run on that device as well.
Thank you, Zoran. Andrew, next question for you. I know Zoran mentioned this as well in terms of what you had to do in terms of developing a custom framework for your data, but what other technologies did you consider for your data pipeline, such as Athena, and a little bit about why didn't you go that way?
Thanks, Cameron. So yeah, we did look into concepts of Athena and other forms. As I spoke about earlier, the complexity of the data and I suppose different time series, all the different sensors having their own unique values, I suppose made using those platforms quite difficult compared to, I suppose, the business type data. And I suppose would mean unpacking that data to get it in a structure to work with Athena. We really wanted to, I suppose, our core goal was achieving the automated actions and that process of the defect side of things. So we used Lambda and the event-driven processes to analyze those logs on demand as they came through and to achieve those automated actions. It also pulls out the high-level statistics, and then we can use, I suppose, more standard analytics platforms to review those, statistics at the aggregated level.
Thank you so much. Thanks, Andrew. Zoran, last question over to you. How do you ensure a software update does not cause a problem with a drone?
Well, I touched on that earlier in the presentation, Cameron, and thanks for the question. It's a really good question. So I guess fundamentally it goes to the underlying software or the operating system as we have for Swoop here, having that ability to operate dual images. So really it's about having redundancy built into your product so that if something goes wrong with that second image that you're actually looking to switch over to, or that updated image, for whatever reason, if that fails any of the checks that you put in place, so what we do is we build in a series of self-checks so that when that new image starts up, it'll go through those checks, and for whatever reason, if it fails, it won't actually start up. We revert back to the original image that was on the drone itself. Of course, conversely, if it goes through all those checks, then we're confident that that software got to that drone in a reliable manner, so we can actually then automatically switch across to that new image.
Thank you so much. With that, we have reached the end of the seminar. Thank you for answering those questions, gentlemen. So in terms of the next step, please try AWS for free, get started on building your solutions. And if you want to learn more about DiUS on AWS, please scan the QR code and the URL and learn more about Swoop Aero and Swoop Aero solution on the link provided. Please remember to fill out the satisfaction survey after the webinar. And thank you all so much for attending the webinar today.
Thank you.
Thanks.